Bueno, como les decíamos, una enorme actividad la que tenemos en esta primera jornada del Blockchain Summit Global. Vamos a ir a este nuevo panel que será realizado en inglés, si bien algunos de los miembros están por aquí, por el sur, por Uruguay. El panel estará conformado por integrantes, como les decía, de Uruguay y también un invitado desde Gran Bretaña. En primer término, menciono que estará Diego Suárez, ingeniero en electrónica, magíster en ingeniería biomédica y doctor en ciencias. También nos acompaña Gustavo Giannatasio, Vice Chair de IEE, ingeniero consultor en tecnologías relacionadas con Internet, Smart Cities y IoT. Y también es un honor recibir desde Gran Bretaña al profesor Omer Rama, profesor de Cardiff University, y vamos a pasar al inglés para hacer la presentación correspondiente. Omer Rana co-leads a project investigating the use of blockchain technologies to support GDPR compliance verification for cloud services. He also co-leads the WG on scalable blockchain and parachain under the IEE Technology and Engineer Management Society's Technical Committee on Blockchain and Distributed Ledger Technologies. So you can access to the information about Professor Omer Rana on our website, blockchainsummit.global. Bueno, la moderación estará a cargo de Diego, así que bienvenido Diego, welcome Professor, y bienvenido también
Hello.
Gustavo.
Good afternoon. Good afternoon. I am Diego Suarez. For me, it's a great pleasure to share this panel with two distinguished lecturers like Omer Rana and Gustavo Giannatasio. Hello, Gustavo. Hello, Omer. How are you? Well, today I will be the panel moderator. We will start with 3 slide presentations, approximately 10 minutes per each presentation, and then we will have a Q&A. Well, I will start with the first presentation. The intention is to present application cases, technologies, and visions with no commercial content. So considering this, for this opportunity, I have selected a specific application case that meets the criteria in which I am involved in as head of electronics and nuclear engineering instrumentation laboratory of the Ministry of Industry, Energy and Mining of Uruguay. So I'm going to share the screen. Okay. Well, this is a use case of IoT cloud and DLT technologies applied to enhance particulate matter sampling. Aerosols, or we are going first to a brief introduction. Aerosols or particulate matter are fine solid particles. Its origin can be natural or anthropogenic, and the particulate component size can take values from a few nanometers to tens of micrometers in diameter. The people living in urban areas and environments are potentially more exposed to polluted air. And air particle matter pollution exposure is linked to diverse human health problems and to many environmental effects. The aerodynamic properties of particles determine how they are transported in air and how they can be removed from the air. So these properties also govern how far they go into the air passages of the respiratory system of the human beings. And particles with an aerodynamic diameter equal or less than 10 micrometers are called PM10, can be hazardous to human health, and those less or equal to 2.5 micrometers are called PM2.5 can reach the alveoli during respiration, and eventually some substances can go through the bloodstream. To study particles in air, we use air samplers. After each sampling, particles are collected in filters that are the collected particles are subjected to different diverse laboratory analysis in order to find the causes or the origins of that collected particles. The particle mass concentration can be obtained by means of air sampling and can be used to compute what is called air quality index. Okay, here is a cross section of a high volume air sampler based on an inertial classification system. The weight of the material collected in the filter is proportional to the concentration of particles in air and to the instantaneous airflow. So to determine what is called standard particle mass concentration for the fraction, for example, PM 2.5 in a 24-hour sampling period, we need to know the increment of weight of the filter and also the sampled air volume. Okay, the determination of the sampled air volume is one of the pain points and affects the particle mass concentration accuracy determination. This application case was originated in Uruguay as an unexpected byproduct of a regional project of the International Atomic Energy Agency. That the project is called the Evaluation of Components of Atmospheric Aerosols in Urban Areas for the improvement of air contamination management and climate change. There are 15 countries participating in this project that focuses in the PM 2.5 aerosol concentration in urban areas, and the objectives are to study chemical, physical, and isotopic composition and identification of the main sources. The development and implementation of this case was done by the Electronics and Nuclear Instrumentation Lab at Tecnogestion Laboratories of the Ministry of Industry, Energy, and Mining of Uruguay. So here we have a picture of the air sampler. This is a laboratory equipment. It uses a reference method for air sampling. Once it's calibrated, it relies on the mass airflow controller and on its pump to have a constant airflow rate. But the rate may be affected by some environmental conditions. So this equipment, this is one of the equipment we received. Unfortunately, doesn't have any kind of data storage or data transmission capabilities. So as I told you before, total air sample volume is very important for the calculation of particle mass concentration. So those are some of the reasons that originated the application case. What we did to try to enhance the air sampling process, well, we did two things. We developed an electronic device called RDMA and a software application that runs on the cloud that the user can access by means of a web server and an internet connection. The device is an easy add-on to the existing high volume air samplers. Like at the right, you can see a picture. Well, it sends data to the cloud by means of a wireless connection, Wi-Fi, because it's an urban application and there is Wi-Fi in the places that the air samplers are installed. And the device has an airflow transducer to determine instantaneous airflow and also a shield with some environmental sensors. So the communication between the devices and the cloud is done using this TCP/IP protocol and TLS, and data sent in JSON format is transported using MQTT protocol. A set of topics were defined. The app called Environment Sampling or ERMBAS I make use of some APIs, for example, to get weather forecast data, and the ERMBAS also handles the registers of key sampling variables in the tangle. Well, which are the main functions of the application? Provides real-time data of each sampler. It processes data and sends automatic messages. The start and end of sampling. It creates an automatic files with all the experiment data. It has alerts for flow out of range, device online, offline, and so on. And it also manages the register of the key data in a distributed ledger. Okay, these are some screenshots of the application. We can see here the main dashboard with the data of one of the samplers, some trend graphs, and a map with the location of one of the devices. Well, this is a screenshot of Tangle Explorer. We are seeing here a register made in the August of 2020 in the former mainnet. These are some of the key data. This is no confidential data, so it's not encrypted or we can see the directly using the Tangle Explorer. So what are the summary main benefits? The system provides real-time visibility of the sampling processes, variables for each sampler in the network. It improves the accuracy of determination of the PM2.5 mass concentration compared with the previous method, brings complementary information using for the interpretation analysis. The automatic report generation capabilities reduces human error. We have email alarm event notifications that help us to shorten time to corrective action execution. You also have DLT-based data registering capability useful for resource sharing, quality system, and so on. A recent impact of this project is that the countries participating in the International Atomic Energy Agency regional project showed interest in this solution. The agency is going to support the development, and a network of regional network of devices will be established, enhancing our sampling capabilities. So this was my presentation. I will stop sharing so Gustavo can show.
Thank you, Diego, very much.
Thank you, Gustavo.
Here we are. I'm happy you talk about Iota. So I will try to explain a little bit of that.
Yes.
Let me see. Okay, we're almost there. See if we can start from the beginning. Oh my God, come on. Here. Good. Well, this is the talk about blockchain DLT and especially on Iota, right? Okay, this is the agenda. We'll see challenges that IoT devices put over blockchain, Iota, and many other different DLTs. So to understand that, I will introduce Iota, Hedera, IoT chain, the main features, and some use cases. Okay. This is the main challenge that any IoT device has to be solved by different solutions. Identity, transactions, and interactions. Most of the identity are related to production, asset sharing, etc. Most of the end user authorization are about transactions, authenticate, automate transactions. But in the case of IoT, the management, the interaction between machine to machine, especially in real time, it's the main challenge that IoT has to be solved by different DLTs. Here we have additional challenges. Most of them are easily solved by any DLT, like the off-the-shelf database, API services, etc., peer-to-peer, blah, blah. Everything is solved by any blockchain IoT. But concerning consensus algorithms, we have to see whether the IoT has special conditions to determine which algorithm is better. So I classify the different DLT in this scheme, and you see there you have many different conditions to authenticate, to make peer-to-peer, etc. But basically, we have two different kind of solutions. One is for massive IoT with a star, red star, and the other one is a general use of blockchain with the yellow star. So one of the solutions for massive IoT, massive means a lot of sensors, not just two, three, one weather station, but cars, smart city buildings, etc. So one of the solutions is Iota. Okay. Now, all the different DLTs have many challenges in themselves. For instance, there is a trilemma. You either have to comply with distributed databases with scalability, yes, and performance. And everyone has a different solution, and no one can solve the called trilemma. That is to comply with all the three at the same time, except the last one on red, that is the Iota that Diego is using in his project. Some solutions general, everybody knows, are plenty of solutions from many different vendors, like Ethereum, Interledger, but there are other solutions. Here we have a little sample of other solutions that are not based in chains, but in different combinations of chain and another mathematical solution to simplify and make it accessible to everyone, especially when using multiple sensors. Yes? This is one of the solutions. Hedera, hash graph, is well known. They can handle thousands of transactions per second. This is one of the limitations of the IoT. We have thousands sensors. We need to have the capability to process in almost real time thousands of transactions. So this is one of the solutions. But this Hedera has a drawback. The problem is it's governed by this kind of companies. There are private companies. They can post their governance decisions, and it's not software free or how we call open-ended solution. On the contrary, there is another solution that is called the directed acyclic graph. This is a general category of graph theory that instead of building records, yes, into chains that is shown in the right side of the screen, there are different interactions. Here in the left, you see how it works. A new interaction has the challenge to solve two previous interactions. If he succeeds, he is allowed to enter into the DLT. So this is very light. This is not a waste of time to cycle of 10 minutes between each chain creation. So this is very important for small devices. Another solution is IoT chain. They use a mix of BFT and DAG. So as you see, there are many different solutions, but Iota has some benefits. They can use chain of blocks. There is no miner, there is no cost for transactions. Scalability is endless, and provided you have more interactions, there is more bandwidth. So this here reduction you see in this figure here is not a problem because they are all working, let's say, in parallel. Yes. So it's focalized in machine to machine is optimal for IoT. The consensus is quite light, so it can be ported to the sensors themselves. There are some kind of process like mask authentication messaging to interact between the different sensors, and they have a security mechanism, but somebody tells that it's quantum resistant. So I cannot say that, but that's what is in the discussion today. This is an interesting thing. We can have the upload in the upper side of the screen here, that we move the information from sensor and embedded system like Diego used it through an edge computer to a server and then build the tangle. So we need some kind of intermediate steps. We can reduce this if we can port what is called a client, Iota client, to the edge computer. So in that case, we just need the edge computer to upload information on the Iota tangle. But furthermore, if we could install the client, Iota client into a device, we can solve the problem of sending data without interruption directly to the tangle. This is quite interesting, and there are at least 3 companies in the world that are producing right now integrated circuits that can do this function. The main characteristic of Iota, high scalability, because as it's not block of change of records, it can escalate in parallel. Yes. So the mutual transactions do not cost a cent because it doesn't need any miner to decide whether the transaction is valid or not. It's just a tangle solves that problem without any cost. Transactions can be done in real time. There are no blocks to create, no chains to create. So as you see, the transaction can be almost real time, and this is very important for vehicle-to-vehicle communication. The resources are quite light. So as I said, we can port the client, the IOTA client, into the sensor itself, okay? And most important, the transaction can be done almost without connection. What is this? I will explain in one example later, but you can run a sub-tangle, a sub-IOTA structure, and then connect at the end of that sub-tangle to the main tangle. So you can split, yes, the transactions in a sub-IOTA tangle. If we compare basically different categories of blockchain, hash graph, and DAG, that is IOTA, if you can read there, it's quite small, but actually the scalability is the issue. So this table shows that DAG, that is IOTA tangle, solves quite well the scalability issue. Now we can see some different use cases, mostly in Europe and in America. Mobility. Actually, the cars are digital platforms, so they can pay automatically without any intervention of a third party, without any credit card validator, etc. Parking, charging of batteries, tolls, and many different services. Yes, and also the cars can earn crypto money selling data they generate and providing energy to return energy to the grid when they go home and have still battery available. Also, mobility is interesting because peer-to-peer goes directly without any intermediate party. That is, one car goes to a corner and finds another car coming in that is crossing in red light. So we cannot wait seconds to understand that this is a collision case. So as the machines talk to each other, each car talks to each other, and the car that crosses the red line knows he's crossing the red light because the system, the driving vehicle has that capability, and send that information like, hey, I'm crossing the red light, be careful. So the other car immediately can react and avoid a collision. So this is only possible with real-time or almost real-time transactions. New innovations are possible. So new technologies allow that vehicles have more and more functionalities, and this can be done very easily with this solution. And most important of all is we can feed what is called a digital twin. Digital twin is the digital representation of a physical object like a car, a city, a factory. So everything can be handled in the digital world. So it's very important here that IOTA Tangle provides this without any additional cost because it's open source the non-profit organization backs this development, and you can have the prevention of fraud and different things just checking the digital twin. As I said before, we can interact with the smart grid because every car is a computer itself with sensors and a tangle. We can interact immediately with any smart grid connection. So we can go to a parking place and get energy from the grid, or we can go to a supermarket and get energy from the supermarket vendor, or we can go home and sell the energy we have in excess to the grid. So that makes a very interesting solution for renewable energy. The same is valid for any connected infrastructure like Industry 4.0 installations, etc. This is one example, real example of Jaguar and Rover. They have a core wall. So they can do everything we said before just in the console they have in their car. There is also a solution for future transportation. It's called Orchestra, being built by the European Consortium. This one is also used in Iota.
Gustavo, sorry,
yes.
We have around one minute to round up.
Thank you, no problem.
We are delayed.
Industry 4.0, it's a digital twin connection, digital twins. This is interesting. This is for logistics. The subtangle in yellow allows everything to be connected by the sensors and put into the grid after the flight lands in other place. Smart grid, yes, digital identity, and that's all. So the summary is it's permissionless, decentralized, fee-less, high scalability near real time, low resource requirement, and thank you. That's all I have to say. Thank you very much.
Thank you, Gustavo. Well, please, Omar, can you share your presentation?
Yeah, sure. So thank you, Gustavo. Thank you, Diego. So it's a real honor to be here to present in Uruguay. Let me just share my screen. Okay, let me just get rid of this. Okay, great. So thank you very much. So buenos dias. So have good evening from the UK. So I'm going to talk a little bit about scaling blockchains and IoT and pick up on some of the strands that Gustavo mentioned. You can see my email if there's anything that interests you on the slide. So I'll just kind of start with this context of why we need blockchains in the world today, especially scalable blockchains. So if you look here in this picture on the bottom here, you can see a variety of devices. So you can have mobile and wearable devices. You can have these smart watches. You can have phones in your pocket. You can instrument people really to collect data about them. So that's on one end. As also Gustavo mentioned in his talk, we have a number of vehicles. So many people say that, right, vehicles are going to become more intelligent with electric vehicles, with autonomous vehicles. And the number of what we call ECUs, which are electronic control units in vehicles, are going to grow. And so we have a number of ECUs already in vehicles that drive their behaviors. For example, we can have engine control, the temperature control, for example, of fluids within a vehicle, the way the vehicle accelerates when a person presses a pedal. So all of these are controlled by ECUs connected on an internal bus within a vehicle. So essentially, you can see here that all of these different things here can connect to a network backbone and finally to a cloud environment. So what we do right now is we take data from these devices, we ship it through a network, and then we do analytics on this data in a cloud environment. However, what has happened in the last couple of years is what we would have normally done in a cloud is actually being shifted to the devices themselves. So as the devices grow in their complexity and capability, we have this area called edge computing, which says that analytics should no longer just happen in a data center connected over a multi-hop network connection, but actually analytics should happen in all of these places, right? So we have something called software-defined networks, or SDN. And so essentially what we do is this yellow thing here shows that actually our services, our service provision is actually now based on distributing our capability across a variety of these different layers. And so you can see here, we can do energy trading, we can do device and service tracking, we can do device authenticity checking, and edge analytics or federated learning is in an emergent area where we try to use capability of these devices in order to carry out these operations. So what the major change that represents is a merging of the cloud computing and the telco space into one unified, what we call edge computing environment. You can see that these devices generate different volumes of data and consume different amounts of power. Okay, so what does that mean for blockchains, right? So what that means for blockchains is the moment I open up my number of devices on the edge of the network, it suddenly increases our scaling problem, right? So now we have to take data, we have to shard the data, we have to divide the data into fragments. We can change the size of the block in a blockchain. We can use directed acyclic graphs, very much like in the Iota case. So essentially what we really need today in order to support this kind of scalability is a peer-to-peer approach that can scale as the number of devices increases. So devices taking part in the kind of processing capability. And also we need to understand how mechanisms to verify a transaction. So if a device generates data, or we want to know whether the device is authentic, very much like in the example Diego showed with his sensor calculating air quality, as the number of nodes making measurements increases, we also increase the number of transactions. But the important thing is, right, that often in the proof of work mechanism that often blockchain uses, you have the rich guys and you have everybody else, right? They're big thing called miners, and then who have a lot of compute power, and then everybody else like you and me, right? So the question is, right, that how can we get everybody to participate in this process of validating transactions, and not just the big people who have a lot of compute power. So how you democratize this concept of transaction verification is really a very important part of the scalability challenge that we look at. So the question is, right, that how do we measure whether the blockchain is scalable? Well, we can measure a number of metrics. So the best metric is how many transactions can you process per unit time? So for example, in something like Bitcoin, right, you can have something like 7 transactions per second, right? If you look at an IoT device, right, that's not good, right? So if you look at a typical fintech application like Visa or MasterCard or PayPal, right, Visa processes about 1.7 thousand transactions per second, or 193,000 transactions for PayPal. So if you do 7 transactions per second, right, that's not good. So we need to improve our transaction throughput. We need to improve the storage, right? How much storage? What is the size of the blockchain? So by distributing the blockchain across different nodes, we can also democratize storage. So for example, typically Bitcoin or Ethereum or Litecoin consume about 305 gigabytes, right? So how much is your hard disk, right? So if your hard disk, is typically an SSD is, right, 256 gigabytes, right? You cannot fit all of this stuff in your hard disk. Cost is associated. So how much do you pay per transaction? The latency, that means the time, how long does it take to verify a transaction? And can you have malicious nodes, right, trying to subvert the system? So cybersecurity of blockchains is also very important and becoming more and more significant over time. The other major issue that we're dealing with is energy consumption, right? So what is the energy consumption of a typical blockchain? So Bitcoin, every Bitcoin transaction takes up the order of about 729 kilowatt hours per transaction. That's about 24 US homes, right, per transaction. That's bad, right? It's really terrible because, the UK is hosting the climate change conferences here in November. And if I showed these numbers, right, those guys will swear at me and say, leave the room, why? If your blockchains are taking so much power. So the question is, right, we want something that consumes less power. And proof of work, which is the algorithm, right, that many of these blockchains are using, is very energy intensive. So we need consensus mechanisms that also support energy conservation. So for example, typically the example that Hedera Hedera is significantly less energy consuming than something like blockchains with Bitcoin, for instance. So we need to understand how Tangle, Iota, and the proof of stake, delegated proof of stake, use less energy. This is an example of a graph, right? That in the US, for example, the percentage of energy consumption, right, powered by Bitcoin So in Czech Republic, right, if I ran these transactions, that's equivalent to over 100% consumption, right, of the whole country if I do Bitcoin in Czech Republic, right? And that's not good. So what do we do, right? So the idea of alternative consensus protocols like use of federated Byzantine and asynchronous protocols and something called parachains or layered blockchains are really one solution to help achieve better consensus. So essentially we can use a variety of techniques. Here's a summary. You can read more at this paper, which is a very interesting paper looking at how do we scale blockchains. So one approach is something called sidechains or parallel parachains, where we can have multiple blockchains. You can run a blockchain locally, and then you can have a global blockchain, and then you can peg local and global blockchains together using a technique called merge mining and federated sidechains, or a technique called blockchains within blockchains. So you have a local blockchain that records local transactions, and then we have a federated chain to some global blockchain. And the two can interact with each other using this concept of function-based approximates of what you observe locally. So we have off-chain channels for interaction to limit impact on the main chain, and we can use something called MapReduce from parallel computing as a way to build these parachains. And so all of these are very relevant to Internet of Things and edge computing because they help us to distribute and fragment chains across different devices and the something called edge ensembles that can run part of my overall blockchain. So in the interest of time, I'll just skip this next slide and go straight to a scenario, and I'll just finish there for example, for questions after this. So this is a very interesting picture. This comes from a paper that you can see here. And let me just explain this image to you a little bit. If I have Internet of Things devices in your home, these can be video cameras or your home hub, right? For example, if you use Google Nest, or your mobile phones or any other Internet of Things devices. What this picture shows me is that a device that sits in your home does not just send data to one cloud platform, it actually sends it to many places. So for example, if you have, so this is an experiment done by our colleagues. So we had some IoT devices in the US lab and IoT devices in a UK lab. So the IoT devices like a camera or a home automation system or a smart television was not just sending data to the European Union, but actually was also sending to China and Hong Kong and Korea and Canada and India at the same time. So the person who actually owns this device does not really know where the data is going. They think the data is going to one cloud data center, but actually it's going to a number of different places. And why does that happen? That happens because of advertising, right? So UK devices communicate with Nuri.net, Netflix, and DoubleClick.net. So 2/3 of the parties contacted only by US-based devices were sending data to a variety of different places. So how many of you guys know where your data is going, right? Have you ever tried to audit where your IoT devices in your home are sending this data? So essentially, this is the quantus of this project we have in the UK. We're doing compliance checking of data transfer using a blockchain-based IoT environment. But what we do is every time a user sends the data, every time a user device sends a data, we channel the data through a container platform, which records where the data goes. And what we can do is then, using a blockchain, we can then go and audit the location of where the data is being transferred, but without affecting the performance of the device, right? So essentially, this is a way to do GDPR compliance and data transfer auditing on these devices. And I'll just stop here. So both Gustavo and I are part of this IEEE Technology and Engineering Management Society, which Gustavo has played a very leading role in over many years. I run a working group under that called Scalable Blockchains and Parachains, which is run in collaboration with colleagues from the Montreal Blockchains Lab. If you're interested in any of the stuff that I discussed, please get in touch with us, and it's free to join. Please be part of our group, and would love to hear your thoughts on this. Thank you very much.
Sorry. Okay. Okay. Sorry. Well, we will start with the Q&A. We have received some questions. The first ones are for Gustavo. Can you hear me, Gustavo?
Yes.
Okay. Gustavo, why we should consider a specific DLT for massive IoT sensors, and how does this idea started, and which organizations support this idea? Can you talk about that?
Yeah, that's a very interesting question. And after the excellent presentation of Omer, I think the reply is there. You see everything connected with the transaction time, I mean, non-mining need, etc. So the trilemma restriction, everything goes in favor of not using some chain method, but combination may be possible according to the different solutions. So I thank you very much, Omar, for your clear explanation of why do we have to use different technologies, DLT technologies for IoT. Thank you, Omar.
And what another question? What regarding to attacks? What do you think about the resistance of the consensus to quantum attacks? Gustavo.
Is that question for me? Okay.
Yes. Well, the people send a question for
good.
you.
Okay, good. I don't have the crystal ball. I just know that quantum computing is the end of every cryptography. So every solution, blockchain, Iota, etc., will face a terrible challenge with quantum computing. So they will end everything we have now in our knowledge about cryptography, and that question I cannot be answered right now.
Okay. Here's another one. What can we expect in the roadmap for the Iota, the DLT technology?
Well, actually, they use a trinary system. It's not 1 and 0, but -1, 0, and 1. They use trinary computers. They use winter needs one-time signature. All this complicated mathematics is going to change a little bit in order to make more democratic access. Because if you use trinary computers, you have to put a gateway between the normal devices that are binary to the trinary computers. So they are going to change everything that, and they are going to introduce in the market very, very fast. And they are also doing quick solutions for crypto money, because Iota is not only valid for sensors, data transactions, but also for crypto money transactions. They are just right now building new solutions. They are very, very active.
Okay, I think that in part your answer is a response to this other question. It says additional to machine-to-machine communications, is there other applications? So you have to talk about that.
Well, actually, the cryptocurrency Iota is called Iota, and is gaining value every day. Like every cryptocurrency goes up and down. It's just you have to go and check the market for the pricing. But yes, exists. There exists application for financial crypto money considerations.
Okay. Here we have a question for Omar. Thank you, Gustavo. Omar, we have a question here for you. It says, how DLTs can be deployed in Uruguay, and in particular, how the industrial sector in Uruguay could fully benefit from this technology based on the strengths of the local industry, for example, agriculture, healthcare, oil and gas, amongst others. What do you think about this?
Yeah, I think that it would be interesting to understand, where the key industry sectors are in Uruguay. So, for example, I think it would be interesting to have DLT technologies which are so pervasive that we don't know they're there. So, for example, if they can be embedded within existing IoT platforms. So, I guess the question goes back to, why are we using DLTs? What is the benefit that these provide compared to alternative technologies? And I think these are very well articulated, Diego, in your slides, and also picked up Gustavo. So one is traceability, right? We want to ensure that the data that we collect can be traced and verified in terms of its integrity and authenticity. I guess the other is auditing this data, right? So anytime you have a safety critical environment where you might want to do an audit before something happens or something wrong happens, and you want to go back and verify, what actually happened, do a forensic analysis, I think there again, these kind of DLTs would be very, very useful. I guess my key question here is that the use of DLTs should not be such a barrier in terms of a performance overhead. So if you use something, an application, say in oil and gas or in healthcare without DLTs, it should not add such a big performance overhead that, that people will think that the effort is not worth it. So we need basically low overhead technologies, which can then be pervasive and embedded within other environments, especially in the IoT context. And I think that's where the challenge lies, especially in the sectors, perhaps in the Uruguay context.
Okay, thank you. It seems we don't have more questions. So, well, I think we are in time. Well, we have reached the end of this panel. Thank you very much to the organizers for the invitation, and thank you very much, Omer and Gustavo, for sharing your knowledge and your wisdom with all of us. Both did great presentations. And well, have a good afternoon and keep connected to Blockchain Summit 2021.
I have a final word, please.
Oh, yes, Gustavo.
I just want to reinforce Omer's message that everyone that wants to build the community of IoT, DLT, etc. in blockchain, we have committee groups working on that, and his presentation has the exact address. We will forward that to you. Maybe somebody of you can join our committee. Thank you very much.
And thank you, Diego. Thank you for sharing and your presentation.
Thank you for both and for your time. Great presentation. So keep connected to Blockchain Summit 2021 because great content is coming now. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you.
Bye-bye. Thank you, Diego, Gustavo, and Omer for reaching us and for sharing this time with us.